example number 2 is nice because it has asymptotes involved in as well. So if you have a red pen on this graph, which is the 1 over x graph, you can add the asymptote x equals 0 and y equals 0. And with the equation that we're supposed to sketch, the 4 is on the other side. So far we have liked to have the y by itself. So I'm going to move that 4 to the other side and write minus 4. So a quick description of each of these things. This 1/2, vertical or horizontal? Horizontal, what? Stretch, compression, reflection, translation. It's going to be a stretch. Because if you think about what's happening, you're going to multiply x by 2. So any time that that number is bigger than 1, we're going to call that a stretch. Any time that you're multiplying by something less than 1, we're going to call that a compression. So that's what that does. The plus 1 there. Notice this is in factored form. The 1/2 has been factored out. So this is 1 to the left. And that's a translation 4 down. This is a horizontal translation. This is a vertical translation. So when you go to draw your new graph, what you're going to need is you're going to need a couple of points from your original graph. And when we did the rational graph, I said the only points you're going to need to worry about are 1, 1 right there, and -1, 1 right there. All the other points that are on that rational graph involve fractions. You can use them if you like, but you don't need to. But in addition to those 2 points, we also have to consider what happens to the 2 asymptotes. There's one at x equals 0 and y equals 0. So when we're drawing our arrows, we do have stretches. We do have translations. I'm just going to put brackets for those ones because those are our only points. And we'll do the points first. So the first set of arrows is all of your stretches and all of your compressions and all of your reflections. We only have the one, and that is x by 2. So we can look at where those points go. For the translations, we have 2 of them. We have 1 to the left and 4 down. So 1 to the left will get us to 1, 1. Oops. And 4 down will take us to -3. And 1 to the left here will take us to -3. And 4 down to -5. How do we deal with the asymptotes? Well, the first thing to recognize or to realize that with x equals 0 and y equals 0, when you multiply 0 by anything, it's going to stay 0. The only thing we have to multiply is x by 2. So the only one that could be affected here is the x equals 0. But when you multiply that 0 by 2, it stays x equals 0. Nothing happens to the y, so y stays y equals 0. And you will notice with the rational graph, no amount of multiplying will ever make a difference because they're starting at 0. The only thing that's going to change those asymptotes is translating it left, right, or up and down. So if we're translating to the left 1, it's going to be our vertical asymptote, or our asymptote that's x equals 0, that's going to change to x equals -1. And when we move 4 down, that affects the y, so our asymptote becomes y equals -4. I'm going to draw my new graph on a new set of axes just so things don't look too busy. When drawing graphs with asymptotes, I find it's easiest to start by drawing my asymptotes. So I'm going to draw and label x equals -1, and I'm going to draw and label y equals -4. Once I've got both of those in place, I can now label the points. I've got 1, -3, and -3, -5. And with those points labeled, draw the same shape going towards the asymptotes. Can you see how hard that would be to draw if you didn't draw the asymptotes? You would just have those 2 points and be like, But with the asymptotes there, it does become really clear. Eight and 10 for practice, but we are going to do the next example right away.